into the microphone instead. So I'm the one up here talking, but this is not an effort that I deserve all the credit for. I get a tiny bit of the credit for this. There were a lot of people involved in these trials. Most notably, Dr. Inga Zasada. None of this would have been possible without her leadership in the nematology side of it. Dr. DeVetter, who's been immensely helpful in all aspects of this work. She's a wonderful person to work with. The folks at Trident Ag have been amazingly patient with us as we say, oh, could you do 10 feet of this? Could you do 20 feet of that? You know, they put up with us with a tremendous amount of patience. Probably most of all, thank you. Probably most of all, I've got to give credit to the grower cooperators, because it's not easy for them to have, you know, 5 people sampling in their fields when they're trying to get things done. And thank you to all of you who have put up with that. So fumigation trials, I mean, you all know, those of you who are growers already know why you fumigate. For the rest of you, raspberry growers mostly fumigate for soil-borne diseases, most notably Phytophthora rubi. There's a few other things in there, but it's predominantly Phytophthora, and for nematodes. Is that better? Okay. The nematodes are mostly root lesion nematodes, which spend most of their time in the roots of the plants, but also occasionally dagger nematodes. Growers realize that they do get some weed control from fumigation, and that helps in that regard, but it's probably not the major reason that most growers are fumigating. You know, another reason that they're fumigating is they've lost a lot of the post-plant controls that they used to have. For example, growers used to have Nemacure, so they could deal with nematode problems that happened in the middle of a production cycle. We don't have that anymore. So all the nematode control needs to happen pre-plant or just after planting. So again, those of you who are growers can sleep a little while longer because you already know what your standard practices are. Those of you who aren't growers, you know, the standard practice here is to kill off the old crop sometimes with usually a mixture of Roundup and Crossbow, prepare the ground, get the posts, the wires out, get the big chunks churned up, and then deep shank, and by deep I mean about 16 inches deep, using the kind of rig that you see on the screen there. Deep shank a combination of telone, a nematicide, and chloropicrin, a fungicide. And then it's not a tarped application. Those of you who have been to California have seen a lot of tarped applications. These are non-tarped, but the growers will come through with a roller packer and try to get some kind of a packed top to the soil to resist the fumigants coming out. And then they usually put in a small grain cover crop at the same time. And what does this get for you? Well, for most growers, in most circumstances, you get pretty decent protection from nematodes and diseases for a couple of years. It's not that you won't see any nematodes in the field, and it's not that you won't ever see any diseases, but it reduces the numbers pretty substantially in most cases. Well, what are the problems? You know, what's the downside of it? Well, for one thing, the cost is high, well over $1,000 an acre. And it's rising. Also, as you guys already know, buffers can be a real problem. If you try to fumigate a field all at once, right, you're going to have an enormous buffer, and that's going to be a real problem in a highly populated area like we live in here. So this example here, you've seen this a lot of times. This is a 22-acre field that would be fumigated with a typical application. The buffer, 600 feet. And that includes a number of houses, so that's just not going to happen. So this grower might fumigate the field in sections, but that makes it pretty difficult to coordinate. You have to have, you know, the fumigator coming in on multiple occasions. You can use bed fumigation, you can use a number of other things, but the buffers remain a hassle for growers. So we have a trial that we started in fall of 2014. It's a little more than a year old with Maberry Packing in a field just off of Birch Bay Linden Road. It was a field with pretty high root lesion nematode numbers. So you can see on your slide there, the pre-fume numbers on the roots are about 1,400. That's a lot. That's a lot of nematodes to be starting with. So in this trial, we have 3 treatments. We have the field treatment, that deep shanked one that I just described. And then this grower, Maberry Packing, had a rig where they shallow applied Vapam, which is metam sodium. And by shallow applied, this is applying it at about 5 inches deep and also at 10 inches deep. And they've got a flat roller that you can see behind it. And they're packing it in. So they're applying it much more shallowly than the C35 is. So it's applied at the full rate, 75 gallons to the acre. And then we have another treatment in there. It's a newer product called DOMINUS. DOMINUS is chemically somewhat similar to metam. Metam is a methyl isothiocyanate, and DOMINUS, if I can get this thing to work here, DOMINUS is allyl isothiocyanate. So chemically, they're very similar, and as you'd guess by that, they behave similarly in the soil. The advantage of DOMINUS is that the buffers are only 25 feet, no matter what application method you use. It's got a very strong horseradish smell, so if you are sloppy with it, you will know about it, and your neighbors will know about it. So something to watch very carefully. But the odor does dissipate quickly. The major impediment to DOMINUS is likely to be the cost. I don't have an exact cost figure for you, but it's likely to be more expensive than a straight C35 application. But because of the extremely low buffers, we thought it might have some benefit. All right, here's some root lesion nematode, Pretolenchus penetrans numbers out of these plots that it got these 3 treatments. So there you can see in November of 2014, this is a couple months after fumigation, we've got a lot of nematodes in that cover crop. My gosh, more than 5,000 per gram of root. It's a wonder there's any root in there. But you can see that the numbers are substantially lower for the DOMINUS and the Vapam. About a, what is that? It's more than a 1/10, but it's less than a 1/5. And that held up the following season. So raspberries were planted in there in March, and then we took some samples in July, and same sort of pattern, very high numbers in the field treatment, much lower numbers in the DOMINUS, and very low numbers with the Vapam, and then the same pattern in September. So we have a really consistent pattern of good nematode control with these treatments. Is there anything like magic about just, how about we do questions at the end? Because sometimes I go too long and I don't want to, What's that? I will. Okay. There's nothing magic about the metam and the DOMINUS that they're better than the telone is at killing nematodes. I think what's going on here is that when we look at these crops, what happens in the upper part of the soil is really critical. That's the part of the soil you make the beds with. That's the part of soil you plant your plants into. And that's the part of soil that's the best treated with this shallow injection system, right? The deep shank is going much deeper, but we don't have a tarp on the top. And so we're probably not getting as good a coverage as we really need up in the very top part of the soil profile. So we also took a look at plant growth. We don't have any yield in these because they've just got planted this year, but we did the second best thing. We looked at plant growth. And we found differences. So this is the field treatment, the telone C35. There's about 13 primicanes per hill, and they're about 32 centimeters tall at the time we took the measurements. Well, with both the DOMINUS and the Vapam, we've got more primicanes per hill, and they're taller. So they're responding. They're under much less nematode pressure, and they're responding by growing a bit better. So the experience with this trial has got us wondering more about, what role does that cover crop play in giving nematodes their first home if they've escaped a fumigation? Are we shooting ourselves in the foot with this cover crop somehow? And so what we did was we went to a number of fields here in Whatcom County, and we took samples of the winter wheat cover crop that people had on fields that had just been fumigated. And we got as you would imagine, a real wide range of numbers of nematodes. One field had none, but all the rest of them had at least some. So very consistently, we're seeing at least some of the nematodes in the field surviving on this cover crop. And we also saw that, for example, in field F here, we had about 3 to 4 times the number on the raspberry crop to follow compared to what we had on the cover crop in the winter. Again, here, number C, this is about, I don't know, 4 times as much. Thank you, Sean. About 4 times as much as we had the previous winter. So we're starting to wonder, well, is this cover crop a major source in some fields? Maybe. Here's another couple of experiments that we did last winter. We took a couple of fields that had some nematodes in them that had trickled through a fumigation. And we said, well, let's see if we can do anything to disrupt the nematode life cycle. So here's what we tried. We tried doing nothing to kill the cover crop. We tried doing what I think a number of you guys do, which is kill the cover crop a couple weeks prior to tilling it. And then we tried an early kill, killing it maybe a month or more before tilling. And then we tried applying lanate, which is a labeled application. You can apply lanate to small grains to see if we could reduce the nematode numbers that way. So we tried this in 2 places. And if you're familiar with statistics, you know that we have nothing significant to report here. So no statistically significant results, but there's a tempting trend. When we treated with lanate, we generally had lower numbers. And this is certainly something we would like to revisit and look at again in more detail in the future, because we think there might be an opportunity there to have your cover crop, but not make your nematodes worse. We had another field that we were following. In this case, the grower decided to try in a field with very moderate nematode pressure and no root rot pressure. He said, I'm going to see if I can get by without fumigating this field. So what he did was he left the field fallow for a year, and in that fallow summer, he put in a brassica cover crop. He put in white mustard, Sinapis alba. And then the following year, he planted it to raspberry. And he got pretty good results. You can see on the bottom line here in September of 2015, he was getting about 660 P penetrans per gram of root, which is really on the low end of what we've been seeing in new fields this year. So it worked out pretty well for him in that very moderate pressure field. There's a number of new trials that are underway that are very exciting. Dr. DeVetter has led establishing a new root removal trial. Trident has a new bed fumigation rig, which you can see down here. And we've set up some trials evaluating different products at Larry Tremaine's. Dr. DeVetter has also led our group in setting up a new fumigation trial where we'll be looking at trying to get better control in the upper levels. We're going to compare industry standard with putting a tarp over the top. We're going to compare that with a VAPAM cap, and we're going to compare that with DOMINUS again. So we get another look at that. And then we're doing some more brassica cover crop work with Samson Farms. Sean, how's my time? 5 minutes. Okay, I'm gonna use up just a couple of my 5 minutes here and leave a little time for questions. It was a really dry summer, right? And so for those of you who are gonna try to apply Vidate under the new 24C, did you find any good rainstorms to ground apply your Vidate ahead of in May or June? I mean, I was waiting for them and I couldn't find any. I didn't find any good rainstorms in May or June that I could apply Vidate ahead of and get it incorporated effectively. And what we decided to do was to do a trial with DuPont and Red Raspberry Commission funding to see if we could evaluate the efficacy of applying that Vitate under the 24C through the drip instead of overhead. Because for number one, you don't have to wait for a rain to incorporate it, and number two, you get much better control. You put just the amount of water you want in there, and you don't lose the efficacy of your Vitate because there wasn't enough rain to incorporate it, or waste your Vitate because there was too much rain and it went below the root zone. With drip, you can put it on in an appropriate amount. So we set up a trial, and we looked at Vitate surface applied. This is the standard application that's on the 24C label. We also tried it buried through a buried drip line and through an overhead drip. And then we also tried a couple of newer products. There's a newer product from Bayer that we were trialing, and then a product called Nimitz, which is a reduced risk organophosphate that's coming onto the market. And making a long story short, so we got a little time for questions, we didn't see any differences in any of these things and how they affected the growth of the plants. Didn't see any differences in July root lesion nematodes, but we did see a difference in September nematodes. And the happy news for us is that we did get better control. We got good control with the buried and overhead drip. It seems like it was at least as good, probably better than the surface applied Vitate. And we got some good leads on Nimitz, looked pretty good here. And then in the roots here, the Bayer product looked pretty good as well. So we have a couple of leads on some products that appear to be promising at this point. And my understanding from talking to Norm at DuPont is that he is going to see if they can get the drip application put onto the 24C label so that you can use it if you want to. That's all that I've got, and if I've got time for questions, I'll be happy to take them. Daryl, I know you got one.
Does fumigation kill weevil too?
Yes.
Okay. And number two, on your VAPAM, putting it in shallow. The reason for putting it in shallow, is it more soluble that part of it will go down?
No, the VAPAM won't go down. It's not very volatile, so unless it gets moved by water or by tillage, it's not going to move much from where you put it. The reason for doing it shallow is that that's only as deep as that rig goes. That's one of the reasons that we're interested in looking at VAPAM as a cap, you know, under a deep shank rig. I think Duncan, who is the next speaker here, is going to talk about where nematodes are distributed in different fields. We may have lucked into a field which, for whatever reason, had most of the nematodes in the upper part of the profile. So what worked in that field might not be a good approach in another field where they're mostly down deep. Maybe where they're mostly down deep, you need those deep shanks. We don't know yet.
What your soil, does it make a difference on what your soil type, whether you have a sandy clay loam, sandy soil, or clay soil?
I think Duncan might be able to help us with that. If there's nobody else, then thank you all very much.
Thanks, Tom.